Welcome to Chemistry 101, and we're working Chapter 3, Selected Problems. Okay, so in Chapter 3, we're going to be doing a lot of naming. So we're going to work some problems here. I like to have my periodic table out when I'm naming compounds. Determine whether a compound containing each of the following combinations of elements is an ionic or molecular compound. I've said that 2/3 of the periodic table are metals. And so these are your metals, folks. We got the metalloids here. So if your first compound, your first element in your compound is any of these selected, this is a metal. And that's going to be an ionic compound. Now, metals bond with nonmetals. So a metal plus a nonmetal, and that will make a compound. And they either have to sum to 0, or if there's a charge, then it has to sum to the charge. Now, metals form positive ions. So we're going to have to, when I say sum to 0, the metal is going to bring a positive charge. And then the nonmetals, and the halogens do not form compounds. So the nonmetal will form a negative anion. Negative ion, negative anion. Anion is more specific, just like a positive is a cation. All right, so let's look at our first element. So here we have nitrogen. Well, where is nitrogen? So that is a molecular compound because you have a nonmetal plus a nonmetal. Because here's oxygen. So that will be molecular. Now, when you do a molecular compound, you have no charges. Okay, so no charges. We do not do charges. Potassium is here, K. So potassium is K, and oxygen here. So this is a metal. And of course, you have a metal with a nonmetal. And this will end up being a +1 because the alkali metals are +1. These are +2. These are going to be variable charges. And then oxygen, the halogens will be a -1. Oxygen, sulfur, that group will be -2. This will be a -3. So you got potassium and oxygen. So that is going to be an ionic. And what you do here is you put their charges that you've memorized from the groups, and then they're going to become subscripts. So K2O. And so potassium, that's potassium oxide. And I'm going to teach you how to do that. That's the problems we're going to be doing. So potassium oxide is an ionic compound. And when you do this crisscross, it'll sum to 0 because there's the subscript K2O means that there's 2 of these. So, and it's a +1 and another +1. So that's a +2. And on the nonmetal side, you have a -2, and there's nothing there, so that's assumed 1, and so that's a -2, and then a +2 and a -2 equals to 0. So when you do this crisscross for your ionic compounds and that becomes your subscripts, it works out to sum 0. Okay, so let's look at our very first one here, phosphorus. Well, phosphorus is P. That's in the nonmetal. So you know you got a nonmetal with the fluorine. You don't do charges here. This is going to be a molecular nonmetal with nonmetal. Okay, and the next one we have is magnesium. Magnesium is here in the +2 column, alkaline earth metals. So you have a metal with chlorine So that's a metal with a nonmetal. That's going to be an ionic compound. And let's see if we can figure out what that formula would look like. Magnesium is Mg. You see it's in the +2, so you put the +2 there. Chlorine is in the -1 column, so -1. And then we do our crisscross to figure out what our subscripts will be. Mg, the 1, so we don't put anything there. Cl, the 2. So it's magnesium chloride. Magnesium, the metal always gets its name, magnesium, and the INE will become ide, chloride. These will always become an ide. So let's just double check that. If there's one magnesium at +2, and so that's a +2 on the cation side, and then you have a -1 and there's 2 of them, that's a -2, that sums to 0. All right, determine if the following formulas represent ionic or molecular compound. All right, once again, do you want me to do the shading again? So if it starts with these here, then anything here is going to be ionic. And if it starts with the nonmetals, it's going to be molecular. All right, so let's start. Phosphorus, right here. Phosphorus chloride. That's a nonmetal with a nonmetal. It's going to be molecular. Lithium, fluoride. Lithium. You see that that is a metal with a nonmetal, ionic. Barium. Barium is a metal with chloride. Barium chloride, that's going to be ionic, metal. N and oxygen, those are both nonmetals. That's molecular. Which of the compounds is expected to have the highest melting point? Okay, so what you need to know, ionic compounds have higher melting points and also boiling points than molecular compounds. And it's like significant, like table salt. Sodium chloride is an ionic compound, and its formula mass, if you add that up, how big it is. Let's see what that would be. Sodium is 23 and chloride is 35, so it's approximately 58 grams per mole. And then you take a compound like methane, CH4, or how about carbon dioxide, CO2? CO2 has a mass of 12 plus 16 plus 16, 44. So this is a gas, carbon dioxide. You can exhale. That's carbon dioxide. That's a gas at room temperature. Sodium chloride is a solid. That carbon dioxide is a molecular compound. Sodium chloride is an ionic compound. So it's very significant. So here we are. Which one will have the highest melting point? Well, lithium is a metal with fluoride, so that's ionic. Carbon dioxide, nonmetal with a nonmetal, that's going to be molecular. And then nitrogen with oxygen, N2O5, is going to be molecular. So which compound would be expected at the highest melting point would be the ionic compound, which is lithium fluoride. Okay, so naming. You need to look at your textbook. I will go ahead and open that. And you need to start working on these. I'd make index cards so you can have some vocabulary 3.17. You also have some tables. Table 3.3 is also 3.3 in your textbook, has some oxo anions. Table 3.4, and then you also have figure 3.17. Definitely read these two pages, pages 98. I would do that to 102 because you're going to have to reinforce this. This will be a significant portion of your exam. So I have a mnemonic to memorize the oxo anions. So what are the oxo anions? Oxo anions. Well, if they're anions, they're going to be negative charges, and they're going to have oxygen. Now, your periodic table, your nitrogens, sulfurs, carbons, chlorines, they like to form bonds with oxygen. And this is just the environment in which we live in. We live in an oxygen-rich environment. So each one of these will form a different number of bonds with oxygen, and they'll have a different charge. And you have to memorize these with the names. So I just think about this camel named Nick, okay? So I'm going to try to draw a camel. Make my little hump. That look like a camel? Looks like a camel maybe squatting, okay? So this is my camel, and his name is Nick. And he is eating, he's eating a clam supper. So he ate, past tense, ate. So Nick the camel. You just memorize the sentence. Ate a clam supper in Phoenix, Arizona. Now you got to know how to spell these. In Phoenix, Arizona. Now you can take the first letter, like Nick. Let's look at Nick. And these are your nitrogen oxo anions. So N for Nick. And then the number of consonants equals the number of oxygens. And the charge is the number of vowels. So how many oxygens are there? How many consonants are there in the word Nick? There's N, C, and K. These are your consonants. So that equals 3. So NO, there's going to be a subscript 3 for the number of oxygens. Now the charge is going to be the number of vowels in this word. So you have Nick is 1. So this is 1. Then you have to memorize that that is nitrate. Okay, let's go to the next word, camel. Camel starts with a carbon. And we're going to put a number of oxygens. We got to figure out how many oxygens and what's the charge. Well, how many consonants are there in camel, the word camel? 3. So that gets a 3 subscript. And how many vowels? You got an A and an E, so it's going to be a 2 minus. And this is the 8s. So this is carbon 8. Carbonate. Clam. Clam is Cl. We don't know how many oxygens there are. How many consonants are there? 1, 2, 3. There's 3. How many vowels? 1. 1 minus. This is chlorate, because Nick the camel ate. Supper. So this is your sulfur. How many consonants are there? 1, 2, 3, 4. There's 4. See, there's 2 P's in supper. How many vowels? The U and the E. It's a 2 minus. This is your sulfate. And then the next one is Phoenix, which is phosphorus. And how many oxygens? Well, you have 1, 2, 3, 4 consonants. How many vowels? O, E, and I. 3 minus. This is your phosphate. Now, you will see all of those are on, that's your table 3.3. But you also see that you have a nitrite. So to get nitrite, the ITE, you decrease the number of oxygens, but you keep the charge. Okay, so we're going to go in. What's less than 3 is 2, and we keep the charge. So NO2 1 minus is nitrite. So I always go to the 8, and then I can get the ites. Carbonite, but that's not one of them. Sulfite. Sulfite, well, this is sulfate. So how will we get sulfite? You drop the number of oxygens, so from 4, you drop it to 3, and you maintain the charge, 2 minus. Phosphite, you drop the number of oxygens from 4 to 3, and you maintain the charge. Chlorite, what do you think chloride is? ClO2, 1 minus. Okay, so name the following polyatomic ions. So what is this one? Well, there it is, right? So this is sulfate. OH, now that is in table 3.4. So some of these you're going to have to memorize. OH is hydroxide. And so I would get an index card and make cards for these. That's hydroxide. ClO4, well, that's, now this is, okay, so you need to go to figure 3.17, and you can see the, we got chlorate and chlorite, and then there's hypochlorite, so you're just going down more, losing another oxygen, but maintain the +1 charge, I mean the -1 charge. But this increases. See this chlorate? You're increasing the oxygen count by 1. And so that's actually, you have to memorize it, that would be perchlorate. So that's perchlorate. Okay, write the formula for the following ions. Now, folks, you have to know this, okay? I'm going to put it in capital letters. When you see IDE, when something ends in IDE, IDE, that's from the periodic table. So whenever you see IDE, you don't memorize these polyatomic ions, you need to look at the periodic table. And so nitride is nitrogen. And so you find nitrogen, it's not the oxoanions, and then you look and it's in the third, it's in the 3 minus column. So that's nitride. Nitrate, this here, NO3, 1 minus. Nitrite is NO2, 1 minus. Write the formulas for the polyatomic ions with the following names. So carbonate. Carbonate comes from what? Camel. Camel. Remember camel? So CO, how many oxygens? 3. Do you see the 8? Nick the camel 8. Those are the oxoanions. There's 3 oxygens, there's 2 vowels, so this is carbonate. Ammonium. This is the only plus, the only cation polyatomic you need to memorize, and that is NH4 plus 1. Remember, the pauses will always be written first in your nomenclature. Hydroxide, I told you just have to memorize that one. That's OH minus. And then I will stay away from a lot of these, but you might have them on your homeworks and stuff. Permanganate, MnO4 minus. I don't have any mnemonics, so that's in your table 3.4. Write the formula of the compound formed by each of the following sets of ions. Okay, this is that crisscross. So these are ionic compounds. You got a metal with a nonmetal, and so when you're writing the formula, you got to sum to 0, so that you got to figure out what the subscripts are. So barium, this is a 1 minus, so we don't put that in, and then Cl, the 2, it will be there. And so that's barium chloride. Barium gets its name, and then chloride It's from the periodic table, and the ine becomes ide. And you can check that 2 plus here, and then the 2 times negative 2 is 2 minus, that sums to 0. Okay, so let's do iron bromide. And then the 3 would go here. So that's iron bromide. Calcium phosphate. Okay, so you get 3 calciums. Now, whenever you need more polyatomics, so you need 2 polyatomics, you have to have parentheses. That's the only time you put parentheses. If you put parentheses and you don't need them, it'll be wrong. You'll minus a point. Okay, so you only use parentheses if you have greater than 1 polyatomic. All right, let's do the chromium Cr3 plus sulfate. So chromium becomes 2, and then we need 3 of these sulfates. So that's more than 1, so we got to have parentheses, SO4, 3. And this is, and chromium gets its name, chromium. And then you memorize that that's sulfate. All right, identify the ions in the compounds represented in the following formulas. All right, so we have potassium. You got to get your periodic table out. Where is that? That's group 1, so that's +1. And then bromide is the nonmetal. It's in the group -1. So bromide is -1. Barium, where is barium? Barium is here. This is the +2. So +2 is barium. And then chloride is here. And we're going to have 2, that's the big number, Cl minus. So you got to bring it and represent the formula. So you got to bring it the 2. There's 2 of these. It takes 2. So if you were to figure out what this structure looked like molecularly, you'd have barium here, and then chloride, you'd have to have 2 chlorides on there, and they'd be attached. And so that's, here you could have potassium, and then you could have bromide. All right, so now we have 3 Mg. Where is Mg? Mg is in the 2 plus column, so 3 magnesiums, and then we have 2 phosphates. And what's the charge on the phosphates? You memorize that. Remember, that's the phoenix. So there's 4 consonants, 4 oxygens, and then there's 3 vowels, so that's 3 minus. And the last one, cobalt, CO. CO is in this variable charge. So in order to know what the charge is, we got to look to the, I'll draw some eyeballs here. We look at the anion. So what's our anion here? We don't know what that is. NO3, you know what NO3 is, nitrate. That's Nic. That's nitrogen, because with 3 consonants, 3 oxygens, 1 negative, there's 2 of them. So that's -1, there's 2 of them. Now we know what the charge is, because it has to sum to 0. So if there's 2 times 1 is a -2, and there's only 1 cobalt, this has to be a +2. And that's how we get the charge. And so they're talking about here that we have iron. Iron is in the transition metals. Transition metals form variable charges. So we have to look to the anion. So here we can have iron 2 plus, and we can have an iron 3 plus. And what are the formulas for the compounds if iron forms with oxide? So if you do O2 minus here, and you could do 2O2, but it's wrong because it has to be simplified into lower terms. So that would be, because 2 can reduce to 1 there. What about this one with O2 minus, iron 2, O3, and so there's that. What are the formulas if it forms with the chloride? Well, iron 2 plus and chloride 1 minus would be FeCl2, and Fe3 plus and Cl1 minus is FeCl3. Okay, so let's look at these formulas, determine what is wrong with each, and correct it. Okay, what is sodium? Sodium is a +1. Chloride is a -1. So what's wrong with that? Should just be sodium chloride. The way this is that's a +1, and there's 2 of the -1, that's a -2. That sums to a -1, so that's wrong. KSO4, well, sulfate, SO4, is a 2 minus, and potassium is a +1. So this is a 2 minus, and this is a +1, so it should be K2SO4. So right there, that's summing to a -1. Aluminum is here. That's in the 3 plus, because this is +1, this is +2, this is +3. So aluminum is a 3 plus. NO3 is Nic, the camel. Nitrate, there's only one of those. And if you were to form this compound, it should be Al. We need more, we need 3. We need 3 of these. So we have to have parentheses, NO3, and there are 3 of them. So that would, with a 3 plus, and then 3 times a -1 is a -3, that sums to 0. Here we have 3 times +3 is a +9, and a -1. This sums to a +8, which is wrong. All right, so name the following ionic compounds. So these are all ionic, and we don't have to worry about charges in the name. So the first element is the metal, and it always gets its name. And then if the anion comes from the periodic table, it gets "ide." So the INE gets dropped and made "ide." So this is magnesium, and then space, and then here we have chloride. Here we have aluminum, and then oxygen becomes oxide. Here we have sodium, and then sulfur becomes sulfide. Potassium, K, potassium, and bromine, bromine becomes bromide. Na is sodium, and now we have a polyatomic, and so we had to memorize that. That is nitrate. So sodium nitrate. And then here we have sodium, and we memorize this. I have to think about it. ClO4. So this is 1 minus. This came from clam, and clam is ClO1, 2, 3, 1 minus. So 4 would be perchlorate, because clam with the 3 oxygens is chlorate. So if we increase the oxygen and keep the charge, it's perchlorate. Which of the following compounds must we specify the charge on the metal when we name the compound? Okay, so these are the transition metals. So we're going to have to look at the metal and see if it's in group 1, 2, or 3, then we do not have to worry about the charge. But if it's in this area here, it has variable charges. All right, so we have Mg, magnesium, so we don't have to worry about that. There's Mg. It's in a +2, so we know it's charged, always +2. Manganese, Mn, manganese. Okay, so it is in the transition metal area. So that has to be a variable charge, and so when we write the name of that, we write manganese, and then we have to put the charge in parentheses. And so we have to look to the anion. Remember, you have to look to the anion. So you have SO4, which is a 2 minus, because you think of supper, and that's sulfate. So you have sulfur, you have 4 oxygen. So that's a 2 minus, and since there's only one manganese, there's a Roman numeral 2 for the charge. The Roman numeral is the charge. Sometimes people do that as the subscript, and it's not. Manganese 2, and then sulfate, and that's how you would name that. Okay, calcium. Well, calcium is in the +2, so we don't have to worry about that. Cobalt. Cobalt is in the transition metals, so we have to worry about that. So we have chloride, which is a -1, and there's 2 of them. So this is a -2, so we know cobalt has to be a +2. So then we write cobalt, Roman numerals 2, and then chloride. And then silver nitrate. Silver is always a +1, so some people make you memorize that. I will take it either way. So silver, you can do the 1 nitrate, or you could just do silver nitrate. Write the formulas for the following ionic compounds. So you need to be able to take the formulas and write the names, and then you need to be able to take the names and write the formula. Calcium. So you find calcium. It's in the +2. And so what I do is I write calcium, 2+, and then sulfate. Remember sulfur, Nick the camel. So that's SO4. SO4 2 minus, so that's sulfate. And so when we do the crisscross, that's calcium sulfate. And because it's 2 and 2, it reduces down to just calcium sulfate. Barium. This is barium. It's in +2. So we have barium +2. And then oxide is a -2. Remember, this is -1, -2, -3. And these are +1, +2, and +3. So now when we do our crossover to get our subscripts, it's going to be barium oxide. Ammonium, that was one you needed to memorize. Ammonium is NH4 +1. Sulfate, SO4 2 minus, you memorize that. And so then when you do the crossover, and this is a polyatomic, and we need 2 of them, so we need parentheses, NH4, 2, and then sulfate. That's ammonium sulfate. Barium carbonate, well, we have barium. You know, barium is a 2+. And then carbonate comes from, remember the camel? That's carbonate. That's going to be CO, 1, 2, 3 oxygens, 2 vowels. So that's barium carbonate. And then when you cross over, those will cancel out to reduce terms, and there's barium carbonate. Sodium chlorate. Well, sodium is here. It's in the +1. So you have sodium +1. And then chlorate. Chlorate is clam, and it's an 8. So ClO, there's 1, 2, 3 consonants, 1 minus. So ClO3, 1 minus is chlorate. And then when you cross those over to get your subscripts, you get sodium chlorate. All right, we have another question here. Given the following formulas, what is the name of each compound? I am having trouble seeing that. Not sure what that one is. So I'll skip it. I'm not sure what that is. So water, something with O2. Let's just go on to this one. Okay, so Cr is a transition metal. So that's chromium. And we're going to have to put the charge in the Roman numeral, but I don't know what that is yet. NO3 is nitrate. And I do know nitrate comes from Nic, and that's an NO3 1 minus, and there's 3 of them. So if that's 3 minus and there's 1 chromium, this has to be a +3, so it's going to be a Roman numeral 3. So it's chromium 3 nitrate. The next one is iron. So iron is a transition metal. So we're going to have to put the charge. I don't know the charge yet. And then SO4 is sulfate. And if I look at the sulfate, there's 3 of them. And I know sulfate is a 2 minus, and there's 3 of those. So 2 minus times 3 is a -6. Now notice there's 2 irons. So if I make this a +3 times 2 is a +6, and that will sum to 0. So you can take the negative charge and divide by the subscript to get the positive charge. So we just take -6, divide by 2, we get the 3. So that's going to be Roman numeral 3, iron 3 sulfate. And then the next one is cobalt. Cobalt is also a variable charge transition metal. So cobalt, and we're going to have to put the charge, and then chloride. And chloride is a -1, and there's 2 of them, so times 2 is a -2. Since there's only 1 cobalt, this has to be a 2. So cobalt 2 chloride. Write the formulas for the following ionic compounds. So now we're going to write the formulas. Cobalt 2 chloride, Cl1 minus. And then so we do the crossover CO, Cl2. Manganese, so that's here, Mn, that's the charge, 2 plus. Nitrate is NO3, 1 minus. And so when we cross over, that's Mn. Now we're going to need 2 of these polyatomics, so I need parentheses, NO3, 2. So it's manganese nitrate. Chromium, this is chromium. It's got a 3 plus charge in this compound. And oxide is here, which is a 2 minus. So when we cross over, it's chromium 2O3. That's chromium oxide. And then here we have copper phosphate. So copper is here with a 2 plus. And then phosphate, remember this is phoenix. So PO, we have 1, 2, 3, 4 oxygens. We have 3 vowels. So that's PO4 3 minus. And then when we cross over CU, we need 3 of those. And then for the phosphate, we need 2. So I need parentheses, PO4 2. So that's copper phosphate. Name the following compounds. Okay, this is PF5. These are nonmetals. So you see how phosphorus is a nonmetal and the fluorine is a nonmetal. So these are molecular compounds. And remember I said no charges. So if you look in your book for naming molecular compounds, and we don't do charges, we have to use prefixes. And so your prefixes are table 3.9. And so we don't do mono for the first one. Okay, so we don't do mono for the first one. The second element, 5, if you look, it's penta. So you have mono for 1, di for 2, tri for 3, tetra for 4, penta for 5. So penta is 5, tetra is 4, tri is 3, di is 2, mono is 1. So this is phosphorus. It always gets its name, just metal or non-metal. The first element always gets its name. And then we have 5, so it's pentafluoride. And we still do the IDE. So here, PF3, phosphorus. And then the 3 is trifluoride. This is carbon monoxide. And you see these are all nonmetals with nonmetals, so we don't do charges. Sulfur is here with oxygen, and that's sulfur. And then the 2 is dioxide. Write for the formulas for the following compounds. Once again, we don't have the charges. These are going to be nonmetals with nonmetals, so we're dealing with molecular compounds. Sulfur tetrafluoride. That means there's 4 fluorines. Tricarbon. That's a subscript 3. Dioxide, O2. Chlorine, Cl, dioxide, O2. Write the formulas for the following acids. Okay, acids typically start, when you see acid, you're going to see it starts with a hydrogen. And we'll talk more about acids later on in the semester. So you should get familiar with your strong acids. It's table 3.10. And at some point this semester you'll have to memorize them. So an acid donates an H+. And so when it breaks up, like HF, it breaks up in H+ and F-. Hydrofluoric acid is very bad for you. You need to double glove, and hopefully you won't ever work with it. It can cause your potassium, it can go through your skin and cause your potassium to precipitate out, and you can have actually a heart attack like 12 hours later. And this has happened to people that worked in the lab. So how do you name acids? Well, if it's just 2 elements, so we call that binary. So if it's just 2 elements, so if you just have 2 elements, then you always do hydrofluoric acid. So hydrogen becomes hydro, and then fluoride, we drop the "ide" and it becomes ic acid. So hydrofluoric acid. Now, when you have the polyatomics, you don't do the hydro. It doesn't have the hydro. You don't do hydrogen. It is nitric acid. So the 8s, because this comes, you got to look at NO3, that's an 8, and 8s become ic acid, just like this one, ic acid. Now, the ites become us acid. And let's see if they show you, where's that in your book? Yeah, it becomes us acid. Instead of ic acid, it's us acid. So this would be the PO3, which is 3 minus, comes from, well, phosphate, remember Phoenix, is PO4, 3 minus. So phosphite is PO3, 3 minus. And then it has to have 3 hydrogens to sum to 0. And so because these are polyatomics, they don't start with the hydro, okay? But this is an ite, and ite becomes us acid, so we say phosphorus acid. Phosphorus acid. H3PO4 is phosphoric acid. So phosphorus, actually phosphorus acid. Okay, write the following, the formula. So you have to go back and forth, right? So this is hydrofluoric acid. So we just did that one. Hydro, whenever you see hydro, you can know that it's going to be 2 elements. And the fluoride comes from the periodic table. Sulfurous acid. So it doesn't start with hydro. So sulfurous acid is, well, you think of sulfate, sulfur. Remember supper? And that's your 8s. So this is us acid, so it has to come from the ite. So that's sulfite. And then you need 2 of them. So it's H2. You need 2 positives, 2 hydrogens, SO3. So this is sulfurous acid. Perchloric acid. It comes from, well, the clam. ClO3 1 minus is chlorate. And then so perchlorate is you increase the number of oxygens and keep the charge, so that's perchlorate. And remember the 8s become ic acid and you need 1 hydrogen there. So because it's H plus, ClO4 1 minus, that's HClO4, and this is perchlorous acid, ic acid. The S's are the ites. The S's are challenging. You have to work through these problems. And practice makes perfect. Write the following formulas for the following compounds. Okay, so now we're kind of just merging everything, and you have to kind of just see, like sodium. So you want to always kind of go to the periodic table and see that you got a metal, and then carbonate comes from the 8s. Nick the camel ate the clam supper. Carbonate comes from camel. So that's carbonate. And you got sodium plus 1. And so that's sodium 2 CO3. So that's carbonate. Sodium carbonate. Sodium bicarbonate, you have to memorize bicarbonate, adds actually a hydrogen on that. Sodium bicarbonate, you're probably familiar with it. It's baking soda. So HCO3 1 minus is bicarbonate. And so sodium would be 1 plus. So sodium bicarbonate would be NaHCO3, and that's baking soda. Carbonic acid. Okay, this is an ic acid. So you know ic acids come from the 8s. And so we're looking at carbonate. Well, carbonate comes from camel. So CO3 2 minus. You need how many H pluses? You need 2 of them, right? You do your crossover, CO3. So that's carbonic acid. Sulfur trioxide. Sulfur's here. trioxide. This is a nonmetal with a nonmetal. We don't have to do charges. So it's S, what's the tri mean? 3. 3, so SO3. And then we have copper 2. So now we're looking at a transition metal, TM, and we get the charge here, Cu2 plus, the Roman numeral, and sulfate comes from supper, because it's an 8, supper. So that's SO4 2 minus, and so SO4 2 minus and the 2 plus, that's copper sulfate. Explain why the name given for each of the compounds is incorrect. Okay, so this one's sodium. So they're using prefixes for an ionic compound. For sodium, disodium sulfate. Okay, so that's wrong. Let's name it. It should be sodium sulfate. You don't need to do that because you use charges. All right, so let's go to the next one. Calcium is in the +2. It's not a variable charge. So the problem with this one is they're using Roman numeral for the charge, and it's an alkaline earth metal. And it should be always a +2 charge. So that should be calcium oxide. Going to the next one, copper. Copper is a variable charge, so oxide is a 2 minus. So this should be copper, Roman numeral 2, oxide. So there's no Roman numeral there. And then the last one, phosphorus chloride. The problem with that is phosphorus and chloride are both nonmetals, and we should use prefixes. So if we were to correct that, you would say phosphorus, and there's 5, so pentachloride. Pentachloride. All right, so work through those problems, and we'll see you in class.